All right, let's have a look at 1029. Part A, so we're simplifying each expression, and we are dealing with exponents, as you can see. I'm going to rewrite these because these are really small on my screen, and I'm betting that when I post these as a video, the quality is not going to be great. So let me rewrite A here. We have 5/3 over 5/9. Now, you might recall that when we are dividing, because remember, this division, or I guess not division bar, this fraction bar means the same as divide. So when we do that, when we're dealing with exponents, we want to subtract the exponent. So base stays the same, our base is 5, and we subtract the exponent. So we would be doing 5 to the 3 minus 9th power, which gives us 5 to the negative 6th. Now, we do not prefer negative exponents, and there's something that we can do to get rid of that exponent. And that is, we can switch it to 5 to the positive 6th, but we have to take the reciprocal, which would end up being 1 over 5 to the 6th. All right, and that is our answer for A. Again, you want to make sure you're writing down all of these steps. It's a really important thing to do in helping you to remember and stay sharp at these problems. All right, that was A. I've got to erase so I have room for B. Now, B, I'm going to recopy as well because it's just so tiny. We have A, B, all raised to the 4th over A, B to the 3rd. So remember, if we're looking at the top, I have that 4 exponent, which is outside of my parentheses. And remember, even though my A and B don't have explicit exponents written in, it's technically A to the 1st, B to the 1st. And the same goes for this A down here. Now on the top, we have that 4 exponent outside of the parentheses, which tells us that it distributes to both exponents inside the parentheses. So we're going to have A to the 1st times 4, which is going to give us A to the 4th. Same with the B. We're going to have B to the 1 times 4, which is B to the 4th. And then over A to the 1st, B to the 3rd. All right, so here we are with another division problem. So let's focus on these A's first. Remember, base is going to stay the same, and we subtract exponents. So we would have A to the 4 minus 1. And 4 minus 1 is 3. All right, let's go ahead and have a look at our B's. So base stays the same. My base is B. And we want to subtract. Then we're doing 4 minus 3, which is just 1. Now, I'm not going to draw the 1 exponent in like this, just because it's more mathematically correct to leave it out. If you want to draw in a 1, that's absolutely fine, but it's more mathematically correct to just leave it B and imply that it is to the 1st power. So here is our answer for part B. All right, let's go ahead and move on to part C. Now, I will tell you, for C and D, what I'm going to do is I'm going to factor these out for you. These are both pretty tricky if we're trying to go by shortcuts only. So I do want to work these two out by factoring. So we have for C, we have 8x to the negative 3rd times 8x times 2. All right, so what this is going to look like, we want to focus on this 8x to the negative 3rd first. Now, if you recall, we don't like negative exponents. So what we're going to do is we're going to take the reciprocal and make that exponent positive. So this is going to become 8 over x to the third. So again, that's 8 over x to the third. And that takes care of that part. So we're done with that. Now we want to focus on this 8x times 2. So what that becomes is, if I'm multiplying my 8 and my x times 2, then I could say that it is, let me switch back to my pen. I could say that it is 8 to the second, right? Because 8 times 8 would be 8 times 2. And then x to the second as well. Same idea, because x times 2 is just x times x. All right, so now I've got this new equation. This is not the answer, but I have it set up, and it's set up as a division problem now. So now's the part where I'm going to factor out. Let me do that below here. So on top, I have an 8, and it's going to be times 8 squared, which means it's times 8 times 8, and then times x squared, which is going to be times x times x. And that's all going to be over, what this should have been is, instead of x squared, this should have been x to the third, and that is because this was a -3. So that was my fault. And that's going to be all over x to the third. So that's x times x times x. So what I can do now is see anywhere where I can make giant ones. We want to refrain from using that term cancel out, because that implies that there would be nothing left, but actually it is a giant one. So these two x's would make a giant 1, right? Because x divided by x is 1. And that goes for the same with these two x's. Those make a giant 1. So on top, we're left with 8. You can see we're left with 8 times 8 times 8 times 1 times 1. So a simplified way of writing that would be 8 to the third. And then on the bottom, all we have is an x. So our answer for this one should be 8 to the third over x. All right, you're doing a great job. We have one more left. It's going to be the same idea with part D. I do want to expand it just because this one is a little bit trickier. So we have 1 to the 6th, all raised to the 5th, times 6 to the 3rd. So this is good to factor out right away. So 1 to the 6th, actually let me rewrite it for you because I'm not sure I'm going to rewrite the original because I don't know how well you'll be able to see it on the video, because I know I'm having a hard time seeing it right now. So this is my original equation. Let's go ahead and factor this out. So 1/6 all to the 5th power is going to be 1/6 times 1/6 times 1/6 times 1/6. That's 4. Now 5 times 1/6. All right, so this is a simpler way of representing this, but you can see that I factored it out. All right, my next part is this 6 to the 3rd. So let's write that as a fraction just because we're dealing with fractions in the first part. So I can write 6 as a fraction as 6 over 1, and that does not change the value. So I'm going to do 6 over 1 times 6 over 1 times 6 over 1. All right, so this is a lot to look at. So you can see on the top I have 1 times 1, which is 1, times 1, which is 1, times 1, which is 1, times 1, which is 1. And then I have 6 times 6 times 6. And I could write that as 6 to the third if we're using exponents. Now on the bottom, I have 6 times 6 times 6 times 6 times 6 times 1 times 1 times 1. Well, the 3 ones, that just equals 1, and we have 6 times itself 5 times. So we get 6 to the third over 6 to the fifth. So this is a lot nicer to work with than our original problem, right? We can make sense of this because this is a division problem, and we know here that our base stays the same, so 6, and then we subtract our exponent. So it's 6 to the 3 minus 5. Well, 3 minus 5 is a negative 2, so we have 6 to the negative second. Remember, we don't like negative exponents, so what we can do is we can turn it into a positive, so 6 to the second, but then we have to take the reciprocal, so it ends up becoming 1 over 6 to the second. All right, and that is all for 1029.